Before I start getting into some of the technology considerations, just a few pictures of one of these hospitals that have been completed. So this is Victorian Comprehensive Cancer Centre, or BITEC. So as you can see, it's quite an impressive building. This is a public-private partnership build, which is essentially a design competition to award a successful bidder. So these are some of this is the start of the building and some of the public spaces. And here are some of the clinical spaces. So we've got integrated operating theatre, MRI, another integrated MRI. This is a typical patient room here. The technology there that was selected for that hospital for the patient was a bedside terminal, so that combined entertainment and also the clinicians could use that terminal to bring up clinical information. And that's articulated up by the bed. I'll talk about that in a bit more detail later, because that's a technology that is quite expensive, and we are seeing less of that in the newer hospitals we're doing. And there's a very large data centre in our hospital. Again, that's a trend that's sort of industry moving away from a bit, cloud services and the ability to host off-site. For this particular project, that was needed because there's 4 major hospitals in the precinct, none of them having proper disaster recovery on their IT systems. So that provided rack space for adjacent hospitals like the Women's Hospital, the Children's Hospital, and the Melbourne Hospital across the road, which is the Bangna Hospital. So there's a particular reason why that data centre was so big, but we're not finding that it's a typical requirement in the new hospitals we're doing now. Education spaces. So the BCCC, there was a 10,000 square metres of that space was for Melbourne University staff. So there was a number of lecture theatres, seminar rooms, teaching spaces, and accommodation for academics as well. And that's quite common in Australia that they will affiliate with the university. So they'll have space for university staff. They'll need the network fully to accommodate those staff to have access to their systems as well. Okay, this has got a fair bit of detail on that slide, but it's really just to give an overview on one page of all the technology that went into that hospital. So I'll just go through this quickly. So it was 14,000 active network ports in the facility, extensive wireless coverage, internal and external to the building, large telephone system deployment, wireless address. That's a fairly common requirement in the hospitals we're doing, where we're using the wireless network to provide the transport and the location of someone who is through stuff. Messaging and workflows, 215 patient entertainment cockpits with integration of video conferencing. That was that screen by the bedside that I showed you before. Real-time location system with 5-metre accuracy for asset tracking. So that's with active tags on equipment, so that they can be tracked throughout the facility through an application. General messaging requirements around workflow, messaging system integration to opening phones, pages, smart devices. Integration of all contractor systems onto the network, so that means that it was a converged network. So you don't just have the clinical systems, you also have things like security, building automation, those other systems around the building on the same network infrastructure. VDI and SSO, so virtual desktop infrastructure and single sign-on. So we'll talk about that further on. That basically allows fast access to clinical terminals, and you can use a smart card to tap on, tap off. server and storage environment for a large amount of servers and 6 operating theatres and procedure rooms, and there were other audio-visual spaces in the facility as well. Okay, so what is a digital hospital? So from a technology point of view, I sort of broke that down into the main components that we need to cover in our role as a consultant, so that they're scoped out, so they can be issued to the market, so all the systems can be procured. So the key components are digital workflows. They're defined at a high level at the feasibility stage. So recent hospitals we've done, they've taken a patient-centric approach to the design, and in a digital hospital process is streamlined to create automated paperless digital workflows. So the key thing there is paperless. EMR is another major component. So that's a separate specialised field in itself. And major vendors like Cerner and Epic provide that, through many others as well. But that's to record and accurately track all patient interactions digitally. High availability IT design, which I'll go through in a bit more detail later. And that is providing high availability network support, a reliable delivery of ICT services and all clinical information. Imaging, which is major medical equipment and systems. So that's all the medical equipment like Philips, Stryker, all those sort of specialist medical companies that provide those sort of patient clinical systems, and they're generally integrated into the hospital and the EMR. And then there's general ICT systems that need to integrate with the converged IT design, major medical and the EMR, so everything needs to integrate together if you're going to achieve a digital hospital. Okay, the key technology considerations. So, for a fully digital hospital, clinical information needs to be digital by project conversion. So generally the terms used are paperless and paper-lite. So it really depends which level you're going to get to. High availability. We need to create a network required for the delivery of ICT services and clinical information, redundant network and barrier architecture. Flexibility. So wireless and cable technologies will be utilised to provide performance, reliability and mobility. Training and education. So this is, again, particularly important when you've got university partners. So ICT systems may be required to train students, staff and clinicians at the hospital and suitable facilities. So that includes audio-visual, video conferencing, streaming. Wireless technology, so provide to support mobile devices and location-based services, making bedside devices. So the options there really include integrated type, where you have a bedside sort of terminal on articulated arm or something like that, but there's a number of different services available to the patient, phone, email, movie, music, access to education, that sort of thing. Or there's entertainment only option, which I'll talk about a little bit later. Another key consideration is integration. So integration is all messaging, clinical information, systems onto the IT network, and passed on to mobile devices, generally used by nurses and clinicians. Server, compute and data storage. That includes all hospital applications, building systems, whether that's on-premise or cloud. Storage for AV. So if you have audio-visual in integrated operating theatres and so forth, you might want to store that content. You might want to stream a video conference, all those sort of things, and storage provide for that. Storage attacks and imaging as well. Also, end user devices is a key consideration. So there's a variety of devices proposed. So we have computers in clinical areas, which can be thin client type and support single sign-on, for instance. Tablet computers, PDAs, iPads, so basically mobile devices. Also to the voice side, generally Wi-Fi capable with messaging capability. That's quite important for especially nurse applications. So here's a table of some of the main projects we've done, the larger projects we've done. So these ones here are generally under 200 million US construction, or around 200 million. And these projects here, that's the Children's Hospital, Veterans I spoke about, Sunshine Indigo, and the cardiac one we're doing now. They're ranging from about 500 million to 1 billion US as a total construction cost. Sunshine Coast being nearly about 2 billion construction cost. So the trend is, the larger the facility, especially as new build, the more technology is being design budget. So these are all the IT infrastructure systems. Nurse call, patient entertainment, and down the bottom here we've got things like audio, visual, video conferencing, AV integration into theatres, messaging. So you can see that, these newer, larger projects, there's more of that audio visual integration being included. So I'll quickly go through EMR because it is an important consideration in a digital hospital. So MRAM is the EMR adoption model, which has generally been followed in the Asia-Pacific region. So HIMSS are the organisation that came up with this adoption model. They were established in 1986, and they have a division called HIMSS Analytics, so they're a consulting division of HIMSS. And they created that model, and they also administer that model, and they go into hospitals and they'll score, assess the technology in a hospital and give that hospital a rating or a level. So that's this staged approach. So it's a staged approach that becomes certified as a digital or paperless hospital. And the higher the level, the more difficult it is to achieve. So it measures the degree to which a hospital utilises its EMR functions. And they're stored on standards, digital imaging, interoperability, data security, and a whole range of things. So this is the adoption model. So starting at zero, nothing, gradually moving up to generally stage 6 and 7, who would be considered a digital hospital. So Australia has 2 stage 7 hospitals, one of which is a new children's hospital, which we worked on, and the second one is called Harvey Bay in Queensland, which is stage 7 as well. So significant investment required across IT infrastructure, multiple IT systems and applications to reach that level. So this is really shown off their website. So at HIMSS there's an MRAM section to their website, and they actually go through each stage what generally the requirements are. And these are really clinical based, they're not talking about specific types of technology. It's more the clinical outcomes that they require. So if we look at stage 6, one of the key things in stage 6 is using technology for medication. So have a closed loop medication system. So you're minimising errors and you're making sure that the correct dose is going to the patient and that's recorded into the EMR. So it doesn't tell you how to do it, it's just telling you that's the clinical objective and the technology needs to support that. Level 7, stage 7, paper charts are eliminated, and there's just some additional requirements, including adding in full tracking of blood products and milk products. So again, it's all clinical based. So just on some strategic considerations for the hospital. So the first question we ask is, what is the IT strategy of the health service? So it has to be driven by the health service to become a digital hospital. Also, what stage are they targeting? Are they targeting level 6 or level 7 at opening or in the future? So that you can do your design accordingly and plan your budgets. They might want to have infrastructure for stage 7, but then after opening, then have another stage to actually implementing the systems. So that's the infrastructure, the systems, what level system is required, and that's really the key starting document. It informs consultants like us or integrators what they need to build in terms of infrastructure for the facilities for all the clinical applications. Okay, so with network infrastructure. So generally, the industry standard is to provide a converged network for a digital hospital. This is the old approach, which has segregated networks. So every system will have its own network, independent of each other, air-gapped, no integration. So this really isn't done anymore in Australia, and from what we see in the US and Europe, but we do see it still a little bit in Asia. So the issues with that, there's no connectivity, simple connectivity between systems. There's multiple networks to maintain. They're designed independently, resulting in future integration issues and refresh complexities, which means you need to upgrade one network. What do you do with the others? It's not a converged solution. Also, it's a very inefficient use of infrastructure like space, power, and cooling. So this is a converged approach where these are all the servers for the systems, but they connect to the same network edge, the same switches, separated logically on VLANs or VRFs. You've got a shared fibre backbone, but also shared switching infrastructure, and then you've got a single point of management for your WAN services, etc., and remote access, all those other things. So it simplifies the integration between systems, over you converge like a network, a single network operate, maintain and secure, greater adaptability for future upgrades, changes, reduce total cost of ownership by improving efficiency, and there is greater security through minimising bespoke integration between systems and providing consolidated internet gateway and remote access point. So if you didn't have a converged network, you would have multiple system providers being building engineering systems or clinical systems, and they all have their own method of remotely accessing your network for maintenance support. Very difficult to control the security on that. And also it's very difficult to but have integration between systems. As systems need to integrate going forward, it's a bespoke integration every time. But this solution, everything's on the same IP network, so it's fast enough. The reason I put that up there is we did do a review of hospital link time about 6 months ago, and not only were all the engineering systems set up, but even the clinical. So there was a wide network for the clinical, which picked up basically printers, PCs, thin clients. There was a separate wireless network provided by a private provider, and then there was a separate voice network for telephony. So with that scenario, it's very difficult to have integration with the system. It's just not really achievable. This slide is just an overview of redundancy. So the way to design these networks, basically to provide high availability, you'll have a 3-tier network for distribution access. Everything's duplicated to get high availability. This high availability needs to extend across all your main systems. So this is LAN, this is telephony, so you'll see the same network switch infrastructure for distribution access. Same with wireless, for distribution access, and then your access points. So it can't just be across the wider LAN to PCs and clients, it needs to be applied to your wireless telephony as well. And this is typically how cabling infrastructure will work. You'll have your comms rooms, you'll have your horizontal cabling, you'll have dual vertical fibres down into your core network, and then dual carriers as well. So that's just a bit of a high level. All that physical redundancy requires space. This is a typical comms room, IT equipment, horizontal cabling, space for engineering services. So just to give you an idea, for roughly 2,000 square metre floor plate or floor area, we're looking at roughly 24 square metre communication room, which needs to be planned. Okay, so that just finishes up the high level stuff on network infrastructure. We're moving to systems. So a key system is nurse call. Every hospital will have one. I suppose I'll focus on what the changes are really. So effectively, you have your call points, and you have your nurse stations, and the patient makes a call. There's over-door lights. There's a nurse station gets the call that the patient requires assistance, and potentially that call goes to a wireless device. New technologies include workflow terminals, where you can enter things like patient needs to move to another room, so you might want a bed clean done, and other workflow functions like that. The integration of telephony into the bed panels, so a patient makes a call, the nurse with a wireless device can call back to the patient and find out if it's urgent or not. Do they need to come straight away? Do they just want water in 5 minutes? That sort of thing. So when we're defining the nurse call requirements, this is a useful way to do it, is to do a bit of a workflow of what's required. This is an emergency call scenario. So there's potentially 2 causes or inputs into an emergency call. From a patient monitoring system, a nurse hits a nurse hits an emergency call. And this is just showing the integration between the nurse call head end, VoIP system, and then alarms going to mobile devices. And these are set up through a messaging solution with groups where the clinicians, nurses, or other response staff. This is a bit of a flow chart of when you're planning your nurse call, what are the scenarios that you need to accommodate so that you have all the system integrations covered. This is another application which is fairly common around security cards. So you'll have your security cards for building access, and then they'll also use them for tap on, tap off things like integration to Active Directory and HR. So if someone leaves the organisation and taken off the HR system, automatically they're off the access control system and they don't have access anymore. They also don't have access to their in-client terminals. So again, that functionality and integration needs to be scoped early, because all those integration points and systems, they cost money, they need to be budgeted. slide on the single sign tap on, tap off technology, which is quite common for clinical terminals. So the idea is enter the clinical information in the terminal. The nurse or clinician goes to the next room after that session. So they've tapped on with an access card, they've entered their password. They tap off, they go to the next space, and their session comes up immediately, so within 3 seconds. So when they're doing their rounds, they can go from room to room and do that very quickly. So that requires virtual desktop infrastructure for that to work, along with tap on, tap off technology at thin line. So this is a major provider called Bangna, where you tap your card on the reader, you're immediately prompted for a password, and the session starts. So generally the concept is it's two-factor authentication, so it's something you have on you, which is the card, and it's something that you know, which is the password. So moving on to patient entertainment. This is very common in Europe, quite a bit through the US as well, and in Australia. So this is a Siemens product, which is their cockpit, which provides it's a thin client for clinical use, and it's also entertainment. So it provides all these different services for the patient, and also provides through smartphone integration, clinical log on. So they're generally on dependent, and yeah, as I said, they've been quite common up until recently. The issue with these is they're very expensive. So you're looking at anywhere from $7,000 to $12,000 US per unit for these things. And they take up space, so you might have it on an articulated arm at the bedside. You could ceiling mount them from here as entertainment only, but if they're going to be used for clinical as well, they need to be by the bedside. So that doesn't work for all hospitals, because you might not want the patient disturbed when they're watching their entertainment while they're clinician accessing that client. So what we've seen as a trend more recently is really just keep the entertainment separate, and you might have a wall-mounted screen, and there's plenty of those on the market through the hospitality market, like hotels, that sort of thing. So there's an IPTV back end, for channels, internal channels everywhere. It's integrated to the nurse call handset, just for changing channels and volume. So they can use that. And then you've got content streaming from the patient's their own device, through their phone or their cast or something like that. So this whole setup, you're looking at $2,000 to $3,000 per room. And then if you keep the thin client separate, thin client's going to cost $2,000 or $3,000 an endpoint. So you can effectively halve your cost, and then you don't have that pendant near the bed which gets in the way, and also you're just getting those two distinct functions separate to really accommodate that change in the market where the patient, a lot of them will want to bring their own device and run Netflix or Stan or whatever application for entertainment done with use. You just need to give them access to the wireless network to say, I guess, network. That just summarises it there. So that's probably the biggest change in that patient entertainment space that we've seen in the last couple of years. Another technology that is implemented in hospitals is patient queuing. So, typically speaking, a patient can pre-register at a kiosk, they can get a ticket, they can either stay in the waiting area or go somewhere else in the hospital and get notified of their appointment via SMS or message to their mobile phone. So that can potentially reduce the amount of waiting room seats you need to plan for your hospital. So that's quite a common requirement. again, this is just a bit of a schematic, conceptual schematic of how that might work. And you've got your kiosks, you've got screens in the loading area. You've got integration to the mobile device. Potentially you could give the patient a notification device. Once you might see in cafes and things like that, but they can go away. Others, they come back later. Digital signing and wayfinding, again, quite another technology which is quite common. Wayfinding screens, digital signage. And again, a bit of conceptual schematic of how this might work. So you've got your kiosks, public displays. With integration into emergency warnings is one of the main applications that we see for that. So moving on to visual and telemedicine, which is a rapidly growing area in hospitals. So, with operating in AV, the main complexity is the number of things that need to be plugged in and how to best do that. So there's a lot of clinical devices that are inputs into the system. You want to display them, you want to potentially bring them into video or screen, that sort of thing. So there's a range of things that you can plug in, and they're generally plugged in by anaesthetic pendants. You can't have cables all on the ground or on the floor or anything like that. So these are the sort of pendants. So you've got to get cabling through these pendants to the screens, and there's cameras in theatre lights that have to be considered, and there's also surgical equipment. So this is just an indicative list of some of the things that need to be considered in an audiovisual design for operating video. Here we go with multiple sources. You've got medical equipment, you've got PCs, cameras, audio sources as well. Doctors often like to have music going in the procedure. This is one of those things you have to consider. And video conferencing, and frame grabbing and recording as well. This is an example of the extended cable that needs to be provided for one of these sort of theatres. So that's a patient area, and then there's pendants, and there's a range of data, power, AV cabling that needs to be provided in the planning stage to accommodate these sort of systems. The user interface is also very important. So this is one from a specialist theatre provider called Claveguard. They used to be called Playcom Video, but I think they've rebranded to Claveguard now. So what they do is they integrate a lot of the medical equipment inputs into the user interface. It might be a touch screen on a pendant. So there you've got patient telemetry, you've got all your input control. Examples of interface where that's the surgical camera, that's the frame grab type. They want to take stills and store those, and then video conferencing. So there's a fair bit going on, but the key thing is that interface needs to be intuitive, easy to use for the clinician, and display all the information they need so they can also have what they need for the procedure, and also easily control the AV system itself. Another area, clinical AV systems that we've done on a number of hospitals is simulation centres. Not quite as complex as an operating theatre. That's where you have a setup for a procedure in the theatre. You might have a mannequin, and you've got students and facilitators, and you want to record and control that session. So that's a control room. Area. And there might be a breakout space where the students and the facilitator break out later to watch the session on the room. So this is at Sunshine Coast University Hospital. This is a 4-bed ward. So there's your beds, there's cameras above each bed. There's a significant amount of audio, and this is the control room. This is a typical IPU bed. This is the 2 racks of equipment used to run the system. So this is in addition to the space I talked about earlier for your networking communications. In a simulation scenario, you might have microphones on the students. You'll also have 2-way headsets audio headsets between the facilitator and the control room. There's a lot of audio. So this track is just all audio DSP, and this track, a lot of that's video switching, all the camera inputs and that sort of thing. So that's just another technology consideration for these simulation spaces that you have adequate space for all the equipment to drive the stuff. Okay, so I think we've got 5 minutes left. So the budgets, the allocation and planning. So I'm not going to talk about specific systems because it doesn't really matter too much. With a digital hospital, generally we've found over the last 5-6 years, there's a pretty consistent split between IT communications and AV in terms of dollars. So in this slide, we've got the project here, what type of hospital it was, how many beds, the ICT spend. So when I say ICT, I mean all ICT, the network, the wireless, the telephony, servers and storage, desktop environment, all the communication systems like nurse call, patient containment, digital signage wayfinding, and AV in operating theatres and general treatment rooms, waiting rooms, that sort of thing. So for example, Sunshine Coast, $100 million spend, total construction cost or construction budget is here, and then the ICT is a percentage of the construction cost. So up here, 6%, 4%, 5%, 6%. So these are hospitals completed in the last 3 years. These ones, between 2008 and 2014. So you can see the trend is for the percentage of total construction cost is moving up has moved up from around 2% up to about 6%. So, specifically talking about AV, given that this is an AV conference, is what we've found is that if you do not budget that 5 or 6% on these systems, audiovisual is the first system that gets cut. Because you have to put in a network, you have to have nurse call. These systems you have to do run a digital hospital. Audiovisual is a little bit more optional. I think theatres are important, but in terms of what's the least highest priority, it's usually AV. For example, patient entertainment. That would be one of the things that may not get done if funding isn't there. Okay, so that's the capital budget side. So the split there is your IT budget is about 60% we find, and network, VoIP, telephony, wireless, IT security is about 40%, servers and SAN, your virtual desktop infrastructure, etc. is about 20%. All these communication systems, including patient entertainment, nurse call, about 20%. Audio visual video conferencing, audio clinical video conferencing, maybe training, seminar, general meeting rooms and AV, about 20%. Just to give you an idea of the split we've found. And that's across about 8 hospitals we've done in the finished in about the last 6 or 7 years. So 5 to 10 years ago, it was only 2 or 3%. And probably further back than that, it was probably around 1%. And first hospital we did 40 $20,000 to have some projectors on tables. That was it. So it's a massively growing market in the health field. The life cycle. Now the IT infrastructure, the passive side, cabling, mainstreams, minimum 25 years is the life cycle. Telemedicine AV, 7 to 10. Networking, again 7 to 10. Service storage, 7 to 10. Your desktop probably only 3 to 5. The reason I've got this slide up is I was talking about the capital budget of building a hospital and implementing their systems. But these systems have to be maintained and refreshed. So if you don't also budget with the life cycle, these systems become redundant very quickly, especially the desktop environment. And if you don't have the budget to maintain them, then you can't provide a reliable, high availability service, which is what a digital hospital requires. So, one thing that needs to be considered. Maintenance on a system might be anywhere from 5 to 15% per year, depending on whether you've got in-house technical expertise, and then you've got to allow for refresh the entire system in around these time frames. So, I think I've used up all my allocated time, so just to sum up. So I went through some of the key components and considerations for a digital hospital, application, EMR, all your network infrastructure, some examples of some systems, and some general guidelines on budget allocation and planning. Every hospital is different, but the numbers I've given you, we've found are fairly consistent across jobs that are sort of in the...
And how we deliver that care to patients. What are some of the technologies that will improve some of the overall patient and visitor experience to our hospitals? And how are we delivering that care, the process in which we're delivering that care? And how will technology improve overall patient outcomes? How will hospitals these days benefit from the next generation of technologies, and how can we plan our facilities to be able to accommodate that next generation of technologies? And lastly, how will the safety of our healthcare facilities be planned so we safeguard our assets, including the patients, the visitors, and the clinicians who work within our hospital facilities? So we will answer a lot of those questions during this presentation. Just a quick little background about SM&W and our company. Like Peter's company, we are a design consultancy firm. We focus in ICT technologies, but we also have a very specific healthcare practice that focuses on medical equipment planning and the integration of the medical equipment planning into the ICT practice in terms of support for technology applications within the equipment planning process. So we're going to focus today's presentation predominantly on a lot of the AV technologies within the healthcare environment, AV and multimedia systems, some of the newer innovative technologies that we're seeing in the marketplace today and in the emerging market that can be considered for the healthcare facilities. Some of the health information technology systems that tie these systems and applications together, and then the overall ICT infrastructure that is the utility that brings all of this together. Between AV and IT, those lines have blurred completely. They're really thought of as one component and one system. They are interchangeable. So some of the benefits of advanced technology in the healthcare facilities environment are improved patient outcomes. We're seeing more accurate diagnosis of the clinicians, and we're seeing an improvement in the precision of procedures, whether that's through image-guided surgery, robotics, high-resolution imagery. We're getting a benefit now from these new advancements in technology where we're able to actually have much more accurate procedures thanks to this technology. We're also able to have access to different types of specialists. No longer are we confined to the resources that are directly local within the healthcare facility or within the region for that matter. We have access to specialists around the world. And we're designing hospitals all around the world that have applications for telemedicine to bring in these specialists from the outside into the local market. We're actually working on a project right here, right now, in Bangkok. We're under a fairly strict non-disclosure agreements. We can't talk too much about that particular project. Actually, one of the images I showed there previously was of that project, so you might recognize it. The new site is going to be about 7 or 10 kilometers from here. But this particular hospital, they want to be able to access resources all around the world. They actually have a partnership with some of the Western clinical institutions, and they want to be able to bring those subject matter experts into this local hospital. So we're designing a lot of telemedicine applications to be able to have access to those particular specialists. Having immediate access to patient records, this is something that's incredibly important. Easy, quick access to the electronic health record or the electronic medical record, and having automation of those processes is something that we're seeing as a benefit of technology. And improved response times for emergency situations, whether that's a nurse call system, a code blue system, or even the way that a patient gets processed through an ED, an emergency department. We're seeing great levels of improvement in efficiency and processing of patients. And then we're using things like artificial intelligence and machine learning to help gain benefits from using data and analyzing that data to be able to have very precise processes and delivery of these processes. We're somewhat eliminating the human factor from that, which is good and bad, but we're using machine learning and AI to have much more accurate diagnosis and delivery in terms of the decision-making process. We're also seeing, as far as the benefit of technology, an improvement in the overall workflow and the delivery of care. We're also seeing a great improvement in terms of the operational efficiency of the building or of the hospital. As I mentioned, for patients that are being processed through an emergency department, or even just the administration of checking in a patient and getting them into the system and then checking them out of the hospital when they're done with their procedure. Having automation to reduce the time for a lot of these processes is gaining great efficiencies within the healthcare environment. And it's allowing us to process patients and get better throughput, which ultimately for revenue generating hospitals, which there are many here in Thailand in particular, it helps to generate more revenue. So we have faster access to patient records, which is aiding in this process for efficiency, and we have automation and interoperability between the electronic medical record and the PACS and pharmacy systems. These are all systems that are coming together that are allowing for greater efficiency in terms of operation of the facility. Then we also have things like bed management systems and room scheduling. Again, all applications to help improve the overall efficiency in terms of the operation of the facility. And how can we enhance the overall patient and visitor experience? We have things like digital wayfinding. I'll talk a little bit about some of the newer technologies of how we're using wayfinding to guide people from the entrance into the facility to their ultimate destination. There are lots of new technologies out there that can help with this. Patient entertainment systems, we talked a little bit about that earlier in the first session here. There's new advancements in that can help improve the overall patient experience. Patient status for the visitors, for family members and visitors who are accompanying a patient in the hospital and waiting to have that procedure finished. Being able to have access to real-time information coming off of the electronic health record and access that information immediately so that they're not waiting and wondering what's happening with their family member. And then, the visitor entertainment. Let's not forget about the visitors that are coming in. They're waiting sometimes hours and hours for a procedure. And how can we keep their experience high level? Again, what we're trying to do is improve all of these things. A lot of these aren't necessarily new things, but there are ways to help enhance the overall visitor and patient experience through technology. Peter touched upon medical simulation. We do a lot of work in medical simulation as well, whether that's for a hospital that's affiliated with a university or a teaching hospital. Even non-teaching hospitals are using simulation these days to help train their physicians and clinicians on ways that they can improve their process. So we'll talk a little bit about that. And as I mentioned earlier, improving the safeguarding of assets. Those assets are the patients, the people who work within the hospital, making sure that the environment is safe, using things like video analytics to analyze surveillance feeds and detect things that are abnormal. intelligent access control systems that tie into a building automation system to help automate a process or allow quick, easy access for people into restricted areas. And automated messaging, in the event of an alert or an incident, having quick access to information, whether it's through SMS or through digital wayfinding, but having alerts be instantaneous. It helps to save lives. And then there's certainly a lot of advancements with wireless technologies. Certainly 5G technology is one of those kind of groundbreaking and game-changing technologies. Devices are becoming much more mobile these days, and relying on Wi-Fi isn't always going to be the solution. I think that some of the new advancements in 5G technology with greater throughput, greater speed, less latency, these are really going to be a game changer for especially the healthcare applications. And then of course there's the new Wi-Fi 6, again, that are helping to improve throughput and gain speed efficiencies in terms of faster access to data. Improved space utilization. We're using technologies like occupancy sensing and analyzing data, whether that data is traffic flow patterns or where people are congregating within spaces, using that data to help inform planning of the next stage. And asset management and asset tracking. Those assets, again, could be patients, it could be your staff, it could be the medical equipment, but being able to monitor where devices are in real time. There are pieces of equipment that sometimes get lost within a hospital. We know that there are clinicians and nursing staff that sometimes hide equipment on purpose so they have quick, easy access to that equipment. But knowing where that equipment is and where your assets are in real time can improve efficiency significantly. And as I mentioned earlier, improve building operations. Things like building management systems, automated shade control, and HVAC control. These are all things that are helping our hospitals today and tomorrow operate more efficiently. And we can use technology to help reinforce a brand. That's something that I'll be showing in some of the next slides. Ways to use technology to help build a culture and reinforce a brand of a hospital. And lastly, there are some new advancements in traditional technologies like sound masking systems. I'll get into that a little bit about how we're using advanced technologies for sound masking and paging systems, and more accurately identifying where assets are and paging directly to those particular areas. So again, some of the things that we'll be covering today are some of these spaces throughout the hospital. The visitor entrances are kind of the first area that I'll talk about. We'll get into some of the patient rooms, some of the clinical spaces. Again, we'll touch upon some simulation, and we'll go into some of the telemedicine applications, waiting areas, so on and so forth. So, what we're seeing in terms of new technologies, some of the technologies are actually right downstairs. This is being an AV conference. There are many new technologies out there that we can consider within the healthcare environment that will help improve the overall patient experience. Technologies like this right here, these are LED elements that could be applied to glass. They're things that can be easily integrated into architecture, and no longer are large LED elements big structural requirements. They're becoming much more lightweight and easily an entrance into a facility. We're seeing lots of these applications of LED elements in lobby and waiting areas and entrances into buildings, and they can be applied in many different ways to create dynamic digital content. Content that can capture people, provide, again, an opportunity for culture building. We're talking about a brand and what's important to that particular brand, whether it's wellness or it's organic care, safety in the workplace. These are all opportunities to have dynamic digital content and be able to capture people as they're walking into the facility. This content can also be used for digital wayfinding, being able to find your destination easily and target the content for the specific user. There's new technologies with LED elements that are incredibly advanced, including transparent LED technologies like this here. And this is an LED element that's essentially just glass, and the active components can come alive and You can actually see through the glass. It's, again, about 90% transparent. And you can put essentially any form of content onto this. And the resolution of this type of application is even higher resolution than the other one that was shown 2 slides ago. There's also technologies that have ultra-thin LED elements. In this case, they're OLED, organic LED elements, that allow you to have back-to-back LED elements, right? So it's digital signage in an incredibly thin format, where we're seeing these applications primarily for digital signage opportunities, being able to be integrated into the space architecturally in a specialty way. We're seeing a lot of these LED elements in lobby and waiting areas again, and we're seeing even new technologies for curved LED flat panels. In this particular case, these are fully curved flat panels. No longer do they just need to be a planar surface. These are things that provide opportunities to create a wow factor within the space. Our client here in Bangkok that is developing a private hospital, they're looking for ways to differentiate themselves from other institutions, competing institutions. And just having some technology that can do that, not overwhelming, obviously, for people, but having some technologies that can create some kind of a wow factor and differentiate themselves is what we're helping to discover with our client. Now moving into the patient room. Right, so this is kind of a concept of the patient room of the future, showing a large image at the foot wall of the bed. This foot wall now can be, this foot wall display can be an opportunity for lots of different applications. It could be for clinical applications, remote telemedicine applications, which is what the rendering is showing here, bringing in a remote specialist, or it could have been the physician that was carrying out the procedure. They weren't able to make their rounds, and they're actually doing a remote telesession with the patient that way. They can also be used for traditional patient entertainment. So whether it's internet browsing or watching movies or bringing your own device and connecting to that display and having your own content be shown. And it can also be used for even things like creating an ambiance within the room. And these are some of the concepts that we're actually integrating to a lot of the hospitals that we're working on today. It doesn't necessarily have to be as elaborate or forward-thinking as this. Obviously, a solution like this carries a significant cost, especially if we're talking about a flat LED display, a direct view LED display, and especially something that has a high resolution of under 1 millimeter pixel density. But there are other applications for this. Peter had mentioned systems like these that come in on a boom. So this is another application of how we can bring patient entertainment and clinical applications to the bedside. The upper right image shows, again, a foot wall of how we can have 2 forms of both content for clinical applications as well as patient entertainment. And then you have the more kind of traditional route that might be a bit more realistic in terms of its implementation, and that would be a large flat panel display at the foot wall. These are projects that we've worked on where we've conceptualized some things, but then the reality of budgets kind of come into play, and we ended up providing a solution that becomes much more economical and much more practical for implementation. The key is providing the infrastructure design up front during that planning process so that you can allow for change over time. As we move into waiting rooms, certainly there are opportunities for capturing the people and providing them with forms of entertainment. Some of that is in the form of televisions and flat panel displays, displays that can have access to content that they bring themselves. Everyone these days has a smartphone, so they bring their smartphone, they want specific access to information, and through a wireless connection you can gain that access. We're also seeing a need for entertaining children and providing gaming areas for children. Gamification of data is another trend that we're seeing in the healthcare environment, and being able to provide systems that allow for that children's entertainment as well. And again, providing things like background music and sound masking, keeping these environments acoustically sensitive, and developing an environment that is calming and soothing. not only for the public circulation spaces, but also for the clinical spaces as well. There are many studies out there that talk about how a comfortable acoustic environment promotes wellness. And we're seeing that if we can treat these spaces and provide low ambient noise levels within these environments, especially the clinical areas, it's actually helping to promote organic wellness. So, as I mentioned earlier, we're seeing some new changes in technologies in terms of overhead paging systems. Still paging systems are required in today's hospitals. We need to be able to give an announcement to a staff member or to a department, but we're able to actually now individually address each loudspeaker in a traditional overhead paging system, where through technologies like real-time location services and through ID badging, we can understand where the people or the individuals are that we're trying to locate, and we can direct the page now to a certain area of the hospital. No longer do we have to broadcast that across multiple floors or multiple departments. We can target paging for specific areas, which is definitely a new technology that we can gain a significant benefit from. Creates less distractions, and it targets the messaging for specific individuals. We're also seeing a convergence between traditional background music systems or background paging systems with sound masking systems. And the new technologies for sound masking systems are also tying in biophilic opportunities, which is basically bringing in nature or biological elements into the interior elements of a facility. And what that means is that instead of traditional sound masking, which might be a white noise, a background underlying white noise, we're actually bringing in sounds of nature into the facility. And again, there are studies showing that bringing these elements of nature into the facility are helping to promote wellness. And you can tie that in with also visual cues. The bottom right image there is actually how we can tie audio on the background music side or on the sound masking side of things, of let's say a waterfall or water noises or rain, with a visual element that's much more physical in terms of a water feature within the space. And it helps to, again, provide a connection to the biological elements. Telemedicine suites, we're seeing a big need for telemedicine suites, especially for institutions in this region. Having access to specialists all around the world. This is certainly a new application, and we're able to create spaces that help to promote this with high-resolution displays, low latency, access to video data, and quick and seamless access to the electronic health record, the PACS, any information that a clinician may need to be able to diagnose a situation for a patient and have that communication with the patient. Certainly we want to have good acoustics and lighting within those spaces. So this first image is a little bit advanced and may not necessarily be practical, but we are seeing applications like this where a physician or a clinician comes into a controlled environment, has quick, easy access to patient information, clinical information, research information, and they can have a very direct dialogue with the patient at that point. The patient may not be able to travel to the hospital, and they may be home and or in hospice perhaps. This is a way that they can gain access to care. This is another application of that. Again, a more practical application of telemedicine where a lot of these systems are now going into traditional examination rooms where you have access to data and you have access to subject matter experts outside of the local region. Again, a lot of the healthcare facilities that we are designing here in Asia generally have a clinical partner, perhaps from the States or from another region. And it's a partnership in development of that particular facility where these particular institutions, again, have access to subject matter experts that might be outside of the region. Facility operation centers, we're seeing a big need for this. Essentially, these are spaces that can be used to help analyze data That could be data coming from the building management systems or the building automation systems on ways to manage the facility. It could also be information coming from the clinical applications, from the electronic health record, coming from the asset management system, from the real-time location services. But you have a space where you could analyze data and have quick, easy access for this data. Sometimes these spaces also tie into security operations centers where people are monitoring surveillance feeds and, again, analyzing data and trying to prevent incidents from happening before they actually happen. And using machine learning and artificial intelligence to predict when events may happen before they happen. So I'm not going to go into too much detail about the simulation centers. It was covered in the last presentation. But we design a lot of simulation centers as well. And some of those are for teaching hospitals. But again, more and more we're seeing a need for sim centers within non-teaching hospitals. To keep the staff up to date on some of the latest procedures and ways to practice procedures, ways to improve their skill set. Some of these spaces are dedicated simulation spaces, and in some cases, we're using portable equipment to be brought into clinical spaces so that they could be used for dual purposes. Sometimes when spaces at a very big premium, you have a city like Bangkok where space is at a premium, you could actually have a space be used for dual purposes, for clinical use one day and then for teaching use another day. But being able to have multimedia feeds coming into a control room, analyzing those feeds and sharing that data back with a student or a clinician or someone who's practicing a procedure is incredibly important. We are seeing new technologies like advanced robotics. Robots these days are providing much more accurate surgeries. We are, as our medical equipment planning team, we are specifying a lot of this new technology in terms of robotics, going right into the OR, or even things like drawing blood. It's a little bit scary to think about this, but the accuracy that robotics are providing is amazing. Again, it's removing the human element from a lot of these procedures, which, again, is good and bad, but it's using AI and machine learning to look back at data, look back at procedures that were done that were similar, and using that data to help guide the surgery and have it become much more accurate. So it's really helping to get better outcomes for procedures in terms of the robotics. It's also helping to reduce cost for personnel. Humans in some cases are being replaced, as scary as that sounds, but it's absolutely true. And then we're seeing robotic technologies for things like transporting medicine. We're seeing mobile carts like these that are transporting meds from the pharmacy to the patient. And it's a secure way to transport medicine. It reduces errors. It also allows for handling of sometimes hazardous materials. And within the pharmacy itself, we're seeing advanced robotics for archiving and storing and accessing certain medications. It becomes a very efficient way to have complete access to how you're managing your assets, right? And those assets, in this case, are medicine. And knowing when to replenish things and knowing when you're running low on something and automatically reloading those orders. Having robotics within those spaces allows for all of this automation to happen. Technology infrastructure. We talked about it at the last presentation, and I mentioned this earlier. All of these different applications that we're talking about, they don't work unless you have a properly designed technology infrastructure for your facility. These images here are just showing basic structured cabling. Sometimes it's kind of an afterthought, and it's kind of a given that there will be technology infrastructure, but we can't stress enough that proper infrastructure planning will help provide sustainability for the hospital in terms of technology. It's really the only part of technology that is sustainable. The life cycle changes of things happen so frequently, but the technology infrastructure in terms of the planning of technology rooms, the incoming services, cable pathways, and then the cable plant itself. That's the technology that should be designed as sustainably as possible, especially in a greenfield environment, being a new construction environment. You have the opportunity to design an infrastructure that could last 25 years. The applications and the equipment that tie into that infrastructure will certainly change. Will change in anywhere between 18 to 36 months, a lot of that equipment will change. But if you have the right infrastructure in place, you could forestall a lot of that obsolescence and minimize the amount of downtime to migrate to that next generation of technology. Real-time location services. We're seeing great advancements in real-time location services in terms of asset management, asset tracking, being able to locate your assets in real time. Again, whether those assets are personnel, your clinical staff, or it could be patients. It could be a newborn baby, infant protection systems. These are equipment is being managed. When that equipment is coming to end of life. All of these asset management systems can tie into an active database that allows you to operate your facility much more efficiently. So it knows when equipment is out of life, or end of life, or needs replacement, or needs maintenance. These are things that can be all managed through a nicely planned and developed asset management system. It also allows for things like hygiene compliance and an improved overall clinical workflow. I mentioned earlier about machine learning and artificial intelligence. Again, we're seeing lots of advantages within the healthcare environment with the improvements of AI and machine learning. You have unbiased diagnosis, removing the human factor from the diagnosis and using purely data to make decisions. We're finding that the AI and the machine learning is allowing us to have much more accurate diagnosis of an ailment, as well as the implementation of a particular procedure. Robotic procedures are really relying upon automated robotic surgery, I should say, is relying heavily on machine learning and AI data to practice those procedures. There are forms of robotic surgeries that are human interactive, but I'm talking about the automated procedures that are happening. Again, it's all based upon data, and we're being able to capture this data and feed it into these systems and gain that benefit and that efficiency. These systems are also continuously interfacing with the electronic medical record, getting up-to-date information. So it's constantly updating information and, again, gaining from benefit of that most current information. Ultimately, it improves patient outcomes. So, as a kind of a summary, where are we seeing, where are we focusing our efforts in terms of designing healthcare facilities to accommodate technology? Facilities should be certainly designed with rich technology, but we want to focus on technologies that will, kind of provide the best return on the investment. Providing a wow factor is great, but we don't want to certainly be overwhelming with what we design for our healthcare facilities. We want to be practical in its implementation. Technology changes so quickly, and if there's a big investment in something that might be a wow factor today, 5 years from now, it may not look so great. Right? So you got to be wise about where the spend is. One of the things that we say, especially on healthcare projects, is that technology should be cutting edge, but not necessarily bleeding edge, right? Because bleeding edge technologies are oftentimes unproven. And the worst case to implement an unproven technology is in a mission-critical application like the healthcare environment. So our recommendation is to utilize and implement proven technologies, but still advanced technologies if you're looking to be innovative. Technology should also engage the visitors. That engagement can happen from the moment they enter into the facility, and it can continue on as they navigate and go to their endpoint. And it could even be included as they exit the facility, exit the hospital. So the technology should engage the user, or the visitor, or the patient, and even the operators of the facility themselves. And as I mentioned earlier, the technology infrastructure is the key, making sure that the infrastructure is designed to be sustainable, that it can accommodate flexibility and migration over time, and that is the key component for any planning process. Digital content, you can have the most amazing display technology, but if the digital content isn't dynamic, isn't changing and engaging with the people who are visiting your hospital and becomes stagnant, it really won't be as effective. So, some of the things that we're seeing in terms of trends of digital content is data that's generative, meaning constantly changing, constantly evolving, using data sets to change, whether those data sets are the weather or news patterns, things that constantly change to engage your user and keep that information and content fresh. AV technology and technology in general, it could be ultra sophisticated, but we find that the best technology is technology that can be easily adapted, easily manipulated, and easily managed. Right? So the technology has to be easy to use, otherwise the adoption rate is going to be very, very low. So we need to design systems that are easy to use and intuitive. And then the technology should also be seamlessly integrated with the other health applications throughout the hospital, whether that's the electronic medical record, the building management system, the health information technology systems, the lighting systems. These are all now converging onto a single platform. It's the overall IT platform, and we're using converged networks to bring all of these applications together. But interoperability is a huge component of this, and the success of any technology implementation is in its ability to be interoperable with the other applications and to be able to operate efficiently within the facility. I think that comes to the end. All right, thank you very much. Thank you.